All right, we're gonna do some basic shapes and forms. We're gonna do real simple stuff right now. We're taking like square, which is a two-dimensional shape. Okay, square, two-dimensional shape. And we want to turn it into a cube, which is a three-dimensional form. Okay, so if you just start with that exact same square, there's a couple different ways you could do this. And the simplest way, well, I want to show you first how to do it realistically, and then I'll show you some other simple ways. So you can go up to the right maybe, or you could go up to the left. Why don't we go to the left? We'll put a little dot there, and we're going to use that dot as a guidepost for where we're going to put our lines. So from this corner, we're going to go towards the dot just about that far. Then from down here, we're going to go towards the same dot, about the same distance. And then from here, we're going to do the same thing. This is a little bit advanced right now, but I want to show you accurately kind of how to make it realistic from the get-go, and then we'll show the simpler way to do it. Okay, so that's a cube using 1-point perspective. You'll learn that technique, and we'll spend more time on it in another video. But take a square, put a point in the distance, and use that as a reference to accurately or realistically turn it into a form. And then indicate that it's three-dimensional by putting some shading and some shadow. And the side that's furthest away from the light is going to be the darkest. We'll just leave the top one just white like the paper, and then we'll just put a little shading on this side just to indicate that it's not hitting the light. Will say it's hitting it directly from above and indirectly here, and then it's hidden and there's shadow there. Okay, so a simpler way to do that same thing. I just wanted to quickly show you that. Let's go back to, say, some of you might have done this in your math class at some point in your education. You take a square like that, and then you just draw a second square over here. Now, when you do this, you're just drawing two squares about the same size, give or take. And then you connect the corners, right? And some of you have done this before in your math class. Now, the problem with this is it doesn't really show the depth dimension. It doesn't show that as lines go into the distance as they recede, they get smaller or they get closer together. So technically, this line should be longer than this line. These points should be closer together if you're drawing realistically. But that's a simple way to draw a cube. Let's do another simple way. We'll do similar to this one without the vanishing point. It's called the vanishing point. It just means the point where in the distance you can't see anymore, where all the lines converge. So if we were to draw a similar kind of combination of these two, you could just take these lines and draw them more or less parallel to each other instead of using the point in the distance. And you have the same problem here. It's not a very realistic representation of the 3D aspect, but it still looks like a cube. And when you draw, you're just trying to create little illusions, and a lot of times, that works because people just, they don't necessarily always notice the three-dimensionality of it. But this is more realistic than that. But let's do another way to draw a cube. And instead of starting from a square, we're going to start this time from a diamond shape. So you're going to make a diamond shape, or a parallelogram, if you will. You're basically going to draw two parallel lines here and two parallel lines there. Okay, that's still a two-dimensional shape. It's not a square. We'll just call it a diamond. In order to take this shape and make it three-dimensional, you just give it some vertical lines. One there, one there. Now, because these 2 points are about on the same horizontal plane, and this one is lower than those, the bottom of these 2 lines should be higher than the bottom of this line that you're going to draw. I'll just show you what I mean. Draw this one a little bit longer than those 2, right? The distance from here to there should be similar to the distance from there to there, and you can accentuate it even more if you want to make make it a little more 3D-ish. But basically, there's another cube. So light coming from over here, shadow will be on this side, and if you want to give it just a tiny bit more realism, tiny bit, darken this side a little more than the other one. Okay. 2-dimensional shape, 3-dimensional form. 2-dimensional shape, 3-dimensional form. Now, since we did it here, why not? Why not just jump into something a little more complex? Let's take this same cube, but this time we're going to start by drawing this, and we're not going to be able to see the top of the cube this time. It's going to be interesting. We're getting ahead of ourselves a little bit, but that's okay. It's kind of fun. So remember how we put the dot in the distance over here? Well, let's just put a dot right about there, and we'll put another one over here. And we're going to use this to guide our line from the left, above, and from the right, below. And then we're going to draw a vertical line parallel to that. You see? And we'll do the same thing over here, going towards that. I'm not using a ruler, I'm just approximating. I'm not doing it perfectly, I'm not doing it exactly. But now you see a cube, and now it looks like we're looking below, or looking down at the bottom of it, and we're looking up at the top. So it kind of looks like a building, really. Okay, what we just did is kind of a slightly more advanced drawing technique. We'll learn it in this class. It's not really that advanced, but it's a basic technique you don't usually learn in the first couple days. It's called 2-point linear perspective, what we just did. And usually you draw the horizon line in the background. Why not just put it there? Anyway, so there's a square and a diamond, flat 2-dimensional shapes turned into cubes, 3-dimensional. Flat 2-dimensional are referred to as shapes. Voluminous 3-dimensional are referred to as forms. Shapes are flat, forms are 3D. They have volume, let's just say. Okay. Let's see if we can see that. Yeah, let's stop there for now.